Hello and welcome, everybody. Good afternoon to Europe. Good evening to Asia. Good morning to the US, wherever you're calling in from today. And welcome to the Spicy SE webinar on reusing system models. Now, why are we doing a webinar on reusing system models? Why is this becoming more and more important? On one hand, we see an increasing complexity, basically in all industries, and a higher specialization, therefore, more internal and external suppliers supplying systems into system of systems, component to systems, and so forth. And also, of course, we're seeing times to market decrease, making it important for us to iterate quickly and push the next iteration out of whatever we're building in shorter time. So for that, wouldn't it be great if we could reuse what we've already done? Yeah, my name is Robert. I'm one of the founders of Spicy SE. And joining me today is Torben, who will be watching the chat and answer all your questions that you might have. Yeah, by the way, this meeting is being recorded, but I believe you will not be visible on the recording afterwards. So let's get into it. Reusing system models. We all know systems, we all build systems, we all have a product that we are passionate about, that we're developing for, that we're pushing to market. But now we see a trend, and we see a trend that's going towards system of systems. One example I'd like to make, which for me is the biggest one at the moment, is the defense industry, where we're going from building a ship, a tank, a drone, into building these combat systems, where all of these already complex systems also need to interact and communicate with each other. But not only in the defense sector, but basically in every industry, we have this trend towards the system of systems. Also, we see that when we develop a system, we develop components to make that system possible. And sometimes we discover that our component is so amazing that it has other applications too. We see that a lot in spacefaring. So things are developed for space, like the Teflon frying pan, that then comes back around to, so this development, this discovery leads us to other related systems. And so these components could be either internally supplied by our own organization, but maybe by a different branch, a different location, a different continent, definitely different team, or even supplied by an external supplier. So that's something that we want to look at today. And as I said before, maybe one of those components is so amazing that we can reuse it to a related system. So you can see there's a lot of things that we can do, or we should do, with reusable system models. But before we do that, before we get into that, and we talk about the models and we add new features to models and more complexity to models, we should talk about the humans. Because humans are actually the ones making the things, right? So in between our rocket, our coffee machine, the shower that you see, and the water heater that you see here, we have human beings, smart engineers developing all these amazing systems. And I apologize if you've been in our webinar 2 weeks ago, because we showed the same slide, but it's important enough to show it twice. If we look at our engineer here, we see that she's contemplating a very difficult technical problem, right? You can see in her face, she's thinking very hard. She has a great idea. And we also see that this idea is taking up all of her brain bubble, right? It's a very complex idea. So she needs her whole brain to think about it. And with this simple picture, we can answer one of the most pressing questions in systems engineering today, which is, why do they always use PowerPoint? We give them these amazing system engineering tools, but why do they still continue to go to the Confluence page and the Excels and the PDFs and so on? And I believe everyone who works as somewhere in the roles of system engineer, lead system engineer, quality lead, has asked themselves this question. Well, the picture we've just seen answers it pretty trivially, I would say. If we look again at our engineer and her brain space, we can see that her brain space is divided. So she has this idea, and now she has the urge to publish this idea, to communicate this idea to her team, to an external stakeholder, to whoever. So in order to do that, she needs to use a tool, a pen at the least, to paint it on the whiteboard. And now we also see that the tool occupies her brain space as well. So is she going to use the systems engineering tool, the complex and hefty 2 weeks of training system engineering tool that we got her a course for last month? Probably not, because this tool will just occupy too much of her brain that she needs now to think about her idea. So where's the idea going? It's going to PowerPoint. And well, is that a problem? Yes, for sure, because in the long run, someone is going to come and they're going to look for information. They're going to look for information about this amazing idea that she had, and they're going to look in the system engineering tool and they're not going to find it. And so then they're going to go on a wild goose chase and they're going to call someone, call in a meeting, have discussions, and of course, that is all going to cost us money. So the first takeaway, it was the first takeaway in the last webinar, and it's the first takeaway again today because it's super important. If you put anything in the brain space of your engineers, that's not innovation, that's not their idea, that's not what they're passionate about, then you're going to lose money. And that's the whole reason why we created Spicy in the first place. We want to focus on the human beings that do not only the systems engineering, but all kinds of engineering. So if I look in the names of the attendees, I see some quite familiar names. So I apologize if you've seen Spicy before. For all of those who have never seen or touched Spicy, I would love to give you a short demo focused on why we made Spicy the way we made Spicy and why Spicy is amazing at integrating everyone. So the goal is we don't want to integrate only the system engineering pros, but literally everyone. So welcome to Spicy to all of those who haven't seen it. Welcome back to current users, evaluators, and other supporters. 3 things I want you to focus on. Number 1, you are still in my browser. So we're focused on the end user and we want to make it as easy for the end user as possible. So no installation, updating, stereotype importing, nothing of that sort. That's all administered somewhere else. To the end user, it's typing a URL in your browser, and there we go. Spicy looks nice for you every day, every morning. A second thing I'd like you to focus on is that with your right eye, you will see something that resembles requirements. You can see that already. With your left eye, you see something that resembles architectures. Now, for us at Spicy, and for me personally, it was never logically understandable why those had to be two very complex tools and then super hard to connect them. The methodologies to connect requirements and architectures exist, but to be honest, I don't like any of them. So in the next minutes, we'll show you how we do that better, more integrated and Spicy. Third thing I would like you to focus on, or better not focus on, you can see there's not many buttons here in Spicy. And it's our goal that I will talk about basic Spicy for maybe 5 more minutes. We believe that you can afterwards join us in a development project that uses Spicy immediately. So there's no need for external consultants to come in and teach you where the tool buttons are. To all consultants who are in the room, that's cool though, because you can really focus on the system thinking and the methodology part and the stuff that's actually fun to consult on. Yeah, so let's get started. Let's build a thing, right? So in the upper right-hand corner, we have our stakeholder requirements. We organize them with these tabs by, of course, the user, service personnel, maybe legal regulations, recycling, manufacturing, and so on. All these stakeholder requirements, which of course we will find an initial set, but then also they need to be updated, right? So one of the first major learnings here is if we don't make it possible for everyone to enter what they learn here, we lose sight of it. In little personal anecdote from my very first internship that I did in a company that made drills for home use, there was a metal part that had a sharp edge. And of course, the sharp edge is dangerous, so it needed to be rounded. And the mechanical engineers in their CAD drawings wanted it to have a rounding of 3 millimeters. And the manufacturing engineer saw it and said, well, we can't do that. We only have tooling for 5 millimeters maximum. So this is usually a conversation that happens on the phone, and people hang up their phone and they go home and they forget about it, right? Imagine if everyone in your organization had access, active access to this system model, and would put this information down as a design constraint immediately, make it a work item that could then be later traced into the overall project traceability. How many repeating conversations, repeating meetings you would save already? So coming back to Spicy, we collect all our stakeholder requirements up here. And now imagine that there's thousands of them. Regulations, customers, maybe they contradict each other, right? And currently what we're doing is we're relying on our amazing heads of our requirements managers to find these contradictions. Well, we can help them. We have amazing AI features like the contradiction wizard. And I'll only tease you about AI today because you can go on YouTube and find the Spicy SE AI webinar. We did that last time. We showed all the cool AI features. Just want to point out that they exist. And if you want to learn more, either call us or it's very findable on YouTube. Yeah, second step is to do a context analysis, which means our system under development is here in the middle. So this is a space tech example right here. And then all these surrounding systems that interact with it, who originate, of course, in the stakeholder requirements, we put them down and we connect the interfaces to them. Again, of course, here, tease, there's also an AI helper to help us make this transition. Go on YouTube, check it out. Now, the cool thing that makes Spicy so nice and easy to use is a simple principle. If I click a thing, I see information, right? So if I click on any interface, I see flows on that interface. If I click on any system boundary, I see the requirements of that system boundary. Now, if I want to link, in this case from stakeholder to system, I select a requirement, I drag and drop it, and then I can see and follow in the linkage view exactly the traceability of each and every requirement. So I can familiarize myself. Let's say I'm a component owner, but has a very small, detailed component, and I don't understand why this requirement is given to me. I can chase it up, the trace. I don't need to talk to anyone, right? It's very obvious why my requirements exist. And anyone can do this. Anyone can drag and drop requirements. Of course, it's also a tedious exercise. There's a link wizard here. Go on YouTube, check it out. It's really, really cool. But also, what we find is that every system boundary carries information. So who's responsible, who's on the review team, and a dashboard for review status, uplinks, downlinks, V&V linkage, test results, and so on, everything that's important. And as you can see, the requirements, and also, but I'm not going to go into that today, the tests and reviews and discussions and all these things, they belong to the system boundary in Spicy. So the linkage is done directly in the data model. There's no need for after the fact manual linkage. It's right there for you. And now, honestly, my favorite feature, it's not an AI one, of Spicy, you can see how we define some interfaces, inputs and outputs to our system boundary. Now, I can jump into the system boundary, taking it from a black box level to a white box level. Let's do that. So what we see now, the system requirements that were at the lower right-hand corner, they move themselves up, and we can look inside. We can look inside of the architecture of our components here. And if I select a component, then I see its requirements, and I can continue linking down. And now, why is that so cool? Why does that make it so easy for? And again, let's put our minds not to the system engineering professionals, and I see a lot of you in the room today, but let's put our mind on these systems engineering novices who are just interested in other things. They might be wing airfoil designers or simulation experts or technical hill experts, whatever they might be. You've seen this level up, level down concept, and probably you said, aha. So as you can see, there's no other navigation. We navigate via the architecture either directly here, or we have what's called the level view, where we see all model system boundaries. So you will find immediately the system boundary relevant to you. Not only you, but everyone in your team will find the system boundary that they are interested in, the thing that they are building. Now you click a thing and you get the information about the thing. Once you click it, you have the requirements, you have the tests, you have the interfaces in and out of your system boundary, and you also have our dashboard, and you can see who is responsible for what's on the other side of your interfaces. So here's where you win with your team, right? Because you can make it super easy for them. You can make it convenient for them. They don't have to look through a really, really long requirement specification. You can do smart requirements engineering to ensure that everyone sees only information relevant to them. And they will thank you for it because you made their life easier, right? And in our experience, it's the only way to convince people to do it if their day-to-day life gets made easier. And that's what we're shooting for with Spicy. Now, back to the PowerPoint. So I'm claiming it's super easy, and Torm is claiming that it's super easy to use, but of course, you shouldn't take our word for it. Now, maybe you can take the word of Sören, who is developing LiDARs for autonomous driving and industrial applications, and who's really, really happy that all of a sudden, more people than ever joined the system engineering model. It used to be just the system engineering experts, and now it's everyone. Or Lydia, who teaches system engineering at university. And of course, she wants to focus on teaching methodologies and teaching the smart stuff, not teaching where the buttons are. So she can do that now using Spicy as well. Matteo, who's building a thing from the ground up. So he's starting what in German is called the green lawn approach. He's doing something fresh right from the start in Spicy, very in contrast to Manuel, who is has the exact opposite challenge. He's in an organization that is very component-based, siloed, different locations, different branches of the company, and he's looking to unify this diverse group of people, and he's doing that in Spicy SE as well. And with that, enough about the humans. Let's get into what we actually came for, which is reusing system models. So I'd like to talk about 3 applications of system model reuse today. The number one being to go from a system to a system of systems. Now, you might say the example I bring might be a bit constructed, but I think it's fun. So we are going to put a coffee machine into the spaceship. And with that, I'll bring back Spicy on my screen. And in my Spicy, I can give you a little tour while I navigate. I see all the products that I have access to, one of them being the spaceship. It also shows me where I'm behind on my reviews and where the automated impact analysis is giving me some tasks to check if some impacts actually have an impact on my development scope. But for now, we want to go to the spaceship. Now, our requirements engineers have not done a great job yet, but they've already extracted 2 very important requirements from our astronauts. Or I shall better say needs from our astronauts. They want hot coffee on their way to Mars. It's a 7-month flight, so of course they need some coffee. And they also want to feel clean and smell nice, so they need a shower. Now, we've seen before, if I click a thing, I see the requirements, I see how they're linked. But what we're interested in is actually the component architecture today. I'll zoom in a bit. I hope it's readable. So already we've modeled the space shower, we've modeled sensorics and a control module and fuel tanks and an engine, and all that's done. But we still need to produce coffee. And we remember, in our company, we've done this before. We've built a coffee machine before. So in Spicy, we go to the product library and check out all the products that we can reuse. And let's take a coffee machine and import it. Now, as you can see, this is green and gray, which means this is read-only here. It's maintained somewhere else. And we are importing a baseline, a snapshot, which is called release G1. Now, I want to connect interfaces to it. And Spicy will tell me now Okay, well, the thing that you imported, it requires interfaces called water, electricity, and coffee powder, and it gives an interface called hot coffee. So that I can see that what I'm trying to do is actually the right thing. So I'm connecting coffee powder, that's great. So I want to create that interface. And now if I go back to my my interface analysis, I can see coffee powder. Spicy things, I did a good job, right? It helps me out, of course. Um, the final say is by the human, but Spicy helps me out here, thinking that I probably did the right thing. Okay, we continue. We connect the hot coffee, yes, and let's continue and connect water as well. And we do the interface analysis again, and we see, oh man, our coffee machine requires electricity. We haven't yet modeled our electric system in our spaceship, so that's something to think about. So already here, we got an impulse on what to do next. But this is how we bring a component that we've already built or a system that we've already built into a bigger context. Now, going back to the PowerPoint, let's look at the second use case we want to talk about, which is reusing a component in another system. So when we think about it, to make coffee, water goes from cold to hot somehow. There must be a component that makes the water warm. And didn't our astronauts want a shower as well? So can't we reuse maybe the water heater from the coffee machine to the shower? Well, let's check out how that goes in Spicy. I'll go right back to our model here. And now this is a baseline, but we can jump into it. So now you see I'm still in the spaceship context, but now if I say I want to see what's inside you, I go level down, and the blue banner up here, or purplish banner, indicates that I'm in a view-only mode of the baseline that I imported. Now I can also switch back to the live project, right? So the coffee machine is maintained in this context, and I can then decide to release baselines, and these baselines can be reused in bigger contexts. So now if I go here down one level, I see the water heating unit. And I believe, this is something that I could reuse. Sorry, I had to laugh about the comment from Retif. No, our astronauts have luxury. They have coffee and hot showers. So now we have a water heating unit, and now we want to reuse this water heating unit. So what we can do is we can tell it to abstract to new product, please. So what it does now, it takes all the information that's stored inside this system boundary and below, and it abstracts it to become its own product. Now, of course, we're showing this live to you. So sorry for the 10-second delay while Spicy has to do some thinking. And yeah, once it's put to the product library, we can see that it makes itself green-gray, indicating that it is now, the system boundary is now not maintained here anymore, right? It is now its own thing. So let's go back to our spaceship. I go back to my Spicy, I scroll down, and I go to the spaceship, and we wanted to reuse the water heater in the space shower. So maybe let me make this bigger for you again so you can read. There's a space shower here, and I go level down, and nothing is modeled here yet, but you can imagine how we do it. It's very easy. I go to the product library, I see my water heating unit is available for me, I select it, and I import it. And that's how easy I can reuse a component from a completely different context in a new context. And what's important about this is that it's not only, and again, I want to stress this, it's not only the system engineering experts in the house that can do it and that can understand how this works. It's very easy. It's very easy to do. It's just a few clicks. The interface analyzer that we saw before will help you out in connecting everything. So make sure you don't make a mistake there. That being said, I'll slide Spicy back over to my other screen and continue to the third and final use case of the day that I'd like to talk about. So imagine that we we don't only get components from our internal stakeholders, from our own company, but maybe also from outside, from our suppliers. Can we use Spicy to help us there? Yeah, of course we can. If I go back one level up to our coffee machine, now we imagine that this is not done by us, this is not done internally. It doesn't matter. We can import a system boundary, a whole product from somewhere else in the Spicy format, as you can imagine, put it in our own system, and import it into our contexts. And now imagine that our coffee machine supplier, they gave us something new. No problem, they re-released it. No problem, we can say, okay, now I want to have gate 3, and it just upgrades it on one right click. And then I also see here in the requirements pane, we can see it, they have given themselves the requirement that we shall produce espresso now. And then we could go on and look into the test cases from there and see if it actually does produce espresso or not. That's reusing system models in Spicy. Very quick, very easy. I hope it was clear. I hope that you now have the feeling that you could potentially use Spicy yourself right now. Let me switch back to the PowerPoint for one last time, because we would like to make you 2 offers. Number 1, we built a thing called the Systems Engineering Return on Invest Calculator. If you're looking to convince your management, that's one of the biggest complaints that we hear a lot, is like, yeah, my management is missing the buy-in and I wish I could show them. Check out this very easy to use system engineering ROI calculator. Basically, you can enter how much time you believe that your people are wasting on useless meetings and chasing down data and so on, and you can make a really good case for systems engineering. And the second thing, if you like what you see and you think Spicy looks easy and you want it and you want to use it, summer is a great time. Everyone is on vacation anyway, so you have the chance to establish some really cool system engineering processes. So we'd love to offer you the Spicy SE summer starter package. Team size is 10 to 15 people. Of course, whether you're 10 to 15 people or smaller or larger, we invite you to scan the QR code on the left. That's always been there. And yeah, and book a meeting with us. Talk to us about anything, reuse, if you like, if this is a topic that that is currently on your mind in your organization, but also, of course, all other topics, systems engineering, we're always happy to chat. Yeah, and with that, I'd love to open the floor to Q&A. And I know Torben has monitored the chat already. Yes, if there are any questions that Torben has not answered yet, please.
So far, there was one question if we can also do a risk assessment in Spicy. I already wrote something about it, but maybe you can also show it in the tool.
Yeah, for sure. So product risks in Spicy are defined on the most upper, on the stakeholder level. And let's just do it live. So the hazard would be astronauts can burn themselves. I know there's a better word in English, with hot coffee. Okay, big risk. We add a risk, and then we can rank the risk also. It's probably very likely. And since they don't have a hospital in space, it's also pretty significant severity. So we rank the risk in that way. Okay, and now here's the problem. We don't have any requirements to mitigate that risk yet. So we'll also add a requirement, and I'd like you to see that when you add a requirement, Spicy already knows which system boundary you're talking about. So this is like a last line of defense of preventing chaos, because more often than not, it happens in organizations that requirements slip the system boundary a little bit. It's really unclear what the system under test is, and so on and so forth. So this is a really nifty small feature that's really cool. Yeah, so the spaceship shall not have any liquids on board with a temperature larger 80 degrees. Maybe this is a good requirement, maybe not. The thing I want to show is that we can link risk, and you can see how Spicy offers me where I can link it to. I can link risk to a requirement, and the cool thing is now we can look at the linkage view, and the risk is directly linked to the first requirement. So what does that mean? We give us a risk, or we identify the risk and we give us a requirement to mitigate that risk. And then we can also prove, of course, that we've broken this requirement down further. And we can also see and test that we've tested it. And so we're mitigating this risk as good as we can. And again, right, we don't need someone super specialized. Anyone can define risks, link risks, and show risk mitigation in any assessment. I hope that answers that question. Does the architecture part in Spicy Tools support System L? No, it does not, and it does not for a reason. As I said very in the beginning of this call, we want to integrate as many people as we can into Spicy. Now, System L is really cool when you speak it and when the other person on the other end speaks it as well. If not, then it becomes a bit difficult because there's a lot of information packed into these System L models, and if you're not 100% confident in reading them, you don't feel like you belong. You don't feel like it's your world. So accordingly, we simplify the modeling language that we use in Spicy to system boundaries and interfaces. This is a language that everyone in the engineering world speaks, that everyone puts on whiteboards all the time, everywhere. And so that way we can ensure that everyone who comes into the tool feels confident. Now, if you need System L, we can for sure convert back and forth. We would need to see the specific use case there, but System L is not available in Spicy, no. And then, thank you, Ahmed. And then Christian asked, how is variant management handled? That's a very good question. Currently, you can do it, I would say, in the old school way, using attributes that you can customize yourself, and then say this requirement is valid for this variant and so on. But that's not the end of the line. You saw the product library today and what we can do with it. And keep a look on your LinkedIn in the next weeks and months. We will release variant management and we'll for sure give a new webinar on that. And Christian, then I hope that we see you again in that one. How well is Spicy configurable in risk assessment? In FMEA, I need to identify failure modes by function and noise effects, then rate the failure and severity. Yeah, so Stefan, one thing we noticed is that all the disciplines basically have tools that they love and use, including the safety and FMEA ladies and guys. So there are amazing FMEA tools out there that we can connect to Spicy with the API. We will admit that there's better tools to do a dedicated FMEA than there is Spicy. What we want to do in Spicy is create this marketplace as exchange for information that everyone can have access to. So if you're really interested, book a call with us, scan the QR code once you can see it again, and let's talk about which FMEA tool you're planning on using, and then we can show you how we can do a bidirectional API connection there. Ali asks, is there a demo version of this tool to work with, including these simple examples? Yes, Ali, there is. Again, talk to us. We'd love to know what your challenges are. And then there's no problem. We'll give you your own subdomain for trying, and we can give you all of these examples and many more. Also watch the YouTube video. There's a really cool magic AI application that we have where we can build a basic model of about anything. Not for production, but for onboarding and to have fun. So yeah, Ali, if you want, talk to us. And yeah, Torben's just posting the link there. Can system requirements and boundaries be cascaded down to the software requirement level and start to define data types with those interfaces, Clint? Yes. The big answer is yes. Maybe let me show you another example that we built back in the day from the autonomous truck. So a bit of background information, both Torben and I, we used to work a lot in automated driving. So this is kind of our home example a little bit. So just to show you, it starts with an autonomous truck. And this is actually the setup of the project. So the way it was set up was that maybe I make this bigger, make it more readable. So we buy a truck in the store that's not automated, that's just a truck, and we put an autonomous driving system on it. So that's why the autonomous driving system is in, that's why it's orange, the truck is out. And also the third-party LiDAR system is out. So this is a system that I cannot have any influence over. And all inside here is what I can have influence over. Now the autonomous driving system consists of sensorics and a main ECU, a main calculation hardware piece. So all of these system boundaries are literal system boundaries, right? They have hardware, they have software, they have mechanics, everything. Now, if I go deeper into the ECU, this is where we draw the split. So the guiding question should be, who needs to read this and what do they get from it, right? And there could be different answers to that. For the way the project was set up at the time, this made the most sense. So you had a hardware system boundary where we talk about PCB boards and heat transfer and such. Base software, bootloaders, all of these things, firmware that I, to be honest, have no idea about. And we define the interfaces between them. And yes, we can define whatever we want, data types and so on. Maybe I'll go into that a bit later. And then we put the driving functions on top. So that's the application layer, if you will, which is where Torben and I come from. That's why also this goes down a bit more in this example. But to answer your question, in Spicy, we have boundaries and interfaces. And these boundaries could be complete systems, hardware only, software only. It doesn't matter. It always looks the same. So that you will always find your way, and the users in Spicy will never be surprised. I hope that answered your question. No, I didn't answer your question to the fullest yet. Let's take a look inside of an interface here. We can always, in every interface, define flows. And we always have the option of defining if it's matter, information, or energy. We can define them on a logical, so a very conceptual level, and then on a very deep down physical level, maybe even a level that we can derive interface specifications directly from. So the way you would do it in the software level is, well, then it would be all information. But the way the interface is defined looks the same. Everyone, all your interns, all your hardware people, they will all find their way if they ever need to. All right, Clint, I hope this answers your question. If not, please write us. I'll go back to the spaceship example for today. Can you handle RecIf? Yes. What other tools can Spicy SE interface with? PTC Windchill. Well, PTC Windchill has a RecIf exporter, so yes, I know that PTC has also an API, so we could also do a bidirectional API connection to PTC Windchill. We have a very open GraphQL API that can basically do everything that I can do manually. Out of the box, for instance, we have connected Jira. So if you want to say, oh, I need someone to take care of this requirement somehow, you can shoot them a ticket straight out of Spicy, or you can connect your baselines to releases in Jira and all. That's very, very, very convenient to establish. So basically, we can connect to any tool that has an API on their end. Torben already said so. Does Spicy support REST APIs or OSLCs? REST API, yes, and Torben also answered that as well. but also a REST API as well. But like Torben said, the GraphQL API is more powerful. Are there any other questions? Please do not hesitate to ask. While we're waiting for maybe another question to come in, you can also, I think, can you unmute yourself? I'm not sure. If you want to know more, please feel free, scan the QR code in the bottom left, book yourself a call with us. We are happy to meet you and have a chat. All right. Thank you for the applause, Ali. Yeah, it looks like the questions are answered. So thank you very much for coming. Keep a lookout on LinkedIn. More webinars will follow, especially the variant management one will follow one of these days. We're looking forward to that. And yeah, thank you, Alexander. Thank you so much. Ottman. Oh yeah, hi Ottman. Yeah, great weekend to all of you. We'll stay in one more minute. If anyone has like a last minute question, feel free to ask it. If not, wish you a great rest of the day and a good weekend.